Hello, everyone. Welcome to episode 48 of the Day Zero podcast. I'm Spectre. With me is Z. Before we jump into topics, we will be having a video coming this week, a discussion video talking about like programming languages and which ones are worth learning for getting into security and stuff like that. That'll be going up on our YouTube on Thursday, which is also where you can find past episodes of the podcast. But yeah, in this episode, we'll be touching on some of the big news this week with We Hacked Apple post that was kind of breaking social media, breaking into virtual vaults, and a new Leakless Heap attack, a new House of attack. So first, we have a few bits of news. One of which is the yearly Google Fuzzing internships being announced. So yeah, Google put out this blog post. They're opening up their internship program again this year for fuzzing-based jobs. They go into detail about what interns have done in the past few years, collaboration on Syscaller, writing entirely new fuzzers targeting Android and Chrome, doing some work with machine learning based fuzzing, Fuzzbench, which we've also covered in this podcast before. But yeah, this might be of interest to some of you out there listening. The only thing is, I think, Z, correct me if I'm wrong here. I think this is only really available to university students that either have their PhD or are going for their PhD or masters or something like that. That's what I could see when I was looking at the positions, but I might be wrong there. I just
I
want to
did
double
not
check.
look at any of the positions.
Okay,
Do you
fair
have any
enough.
of the pages available to pull up? I mean, if that's what it lists as one of the requirements, and that's what it is.
Well, it's just the link they link there is the careers.google.com/students, and the students one is you know, is where all the positions say like all the requirements I saw were like PhD or trying to get a PhD or something. So
Okay. See, so what I'm not sure is I'm not sure if this was their announcement of them doing more internships. So it sounded like when I read this, and what I thought was that obviously they had people doing that this year, and they gave a good overview of some things that were worked on, which I just thought was interesting. Like they, as you're saying, some of the different things they worked on there. I looked at some of the commits the interns had done on like Syscaller and stuff. um
oh yeah, fair enough. They were mostly talking about what was done over this summer. Yeah,
yeah, and
sorry.
it
I did
sounds
kind
like
of
they were kind of happy with how this summer went, so they're going to keep this open, but I'm not sure if there's any listings currently available to apply to that are directly related to this versus some that might just already been open or otherwise open.
yeah, that's fair. I think I got a bit confused because they linked to the careers page, so yeah, fair enough. But yeah, I mean, it's always cool to see some of the stuff that the Google interns have been working on, because obviously all these projects like Syscaller and Fuzzbench and stuff are pretty big projects when it comes to security, especially in the fuzzing area. So some cool insights in that post. We'll jump into CET. So there was a post out by Yarden Shafir, who we've covered some of her posts before. She does research with Alex Ionescu on Windows stuff, and it talks about the Windows CET or control enforcement technology changes that shipped with Windows 21H1. The bulk of the additions they cover here seem to be like the new mitigation flags for eProcess for user space processes, um, and getting some insights out of what they found from those, bit flags and stuff like that. So it seems they added a relaxed mode, which seems to indicate that Microsoft can't implement full control enforcement technology support across all processes. They note that some processes break due to they just can't be compiled with the proper support for it. So this relaxed mode basically disables shadow stack for processes that launch with that flag. So, what they deduced from those observations was that Windows will not fully support CET out of the gate, even though CET support has landed with. I think it landed this year with the Tiger Lake Intel chips, and it might become more available with the Rocket Lake chips at launch in Q1 2021. But it's worth noting that CET is obviously an Intel technology, so that does kind of limit its support already on the hardware front. I don't really think AMD has an equivalent, not that I know of.
Not like anything to feature parity.
Yeah.
That said, I will kind of mention there, like with CT, to have the support for it in like your binaries there, they do have to compile it with that. So that's also part of where Like it's not just about Windows supporting it; it also has to be the application's been compiled to support it. Although there is the strict mode, which apparently will enforce the CET on a process, regardless of whether or not it's actually been compiled for that.
Yeah, which I thought
Oh,
was a bit interesting.
yeah, so did I.
Yeah. Um, CET itself is kind of interesting. There's been some hype around it, I guess, from a defensive standpoint. I've seen the opinion that it'll be a ROP killer, which I guess we'll have to wait and see. I mean, people have said that about other, stuff before, and it just hasn't really worked out.
I mean, it
Um,
definitely introduces some strong mitigations. We were talking about it when Shadow Stack landed. I don't recall what episode that was. I mean, there are generally going to be some bugs to be worked out, some issues to be worked out. As you've mentioned, it is a hardware support thing, but I mean, if Intel's adopting it, and we start seeing this more, especially since people need to compile their binaries for that, if we start seeing more binaries being compiled to support it, I have to imagine we're going to see a response from AMD bringing in some similar support.
yeah, it is. CET seems to be the one thing that Intel still kind of has that AMD doesn't, right? If you just look at like the arms race, I guess, between AMD and Intel, AMD's really caught up, and this year it seems like they've even surpassed Intel. Um, but CET is the one thing where I just can't really find an answer for it. So then again, CET is also probably not something that consumers really care about all that much. It's more something that, um, companies like Microsoft care about. So it'll be interesting to see how much like CET, becomes adopted over the next few
Yeah, I
years.
mean, at the same time, I mean, stuff like NX, had initial hardware support and took a bit of time to get like fully supported, but it did come. And oh no, I think we're going to be facing more systems with CET by default.
Yeah, I think that's a reasonable comparison. So I think what'll be most interesting to see though is how effective it is compared to how effective people think it will be, Um, but I just don't think it has enough adoption yet to be able to really see that.
No, but I mean, there's going to be ways around it naturally. Like it's not going to kill everything. I do think there is going to be a fair impact from it though.
Yeah,
Uh,
I seem to recall when we were talking about a white paper, some of the things like there were maybe some like indirection, like V tables weren't really covered 100% by control enforcement technology, or was that CFG that I'm thinking of?
I'd have to look back on whatever paper you're referring to see, but
Oh, okay,
I
fair
mean,
enough.
we don't have to get into the bypasses right now. I'm just kind of saying, like in general, finding exploits has been fairly resilient through the introduction of new mitigations. I mean, NX and ASLR kind of being the key things there that were thought to be killers, and of course, for a time, they introduced a lot of difficulty, but then it just became kind of standard fare to need to work around them. And I feel like that may end up being the case if we start seeing the CET stuff more. So we start seeing the shadow stack and the CFG enforcement.
Yeah, only time will tell.
Yeah.
So, Binary Ninja, or Vector 35, who we love here because of their community involvement, has open sourced some architecture plugins. So they've open sourced their ARM v7 and ARM 64 core arc plugins, and these plugins are essentially what's responsible for parsing and reading executable files, whether they be ELFs or portable executables, as well as the assembly and disassembly logic of that instruction set. So this will definitely be of interest to people out there who love the nitty-gritty details of how assemblers and disassemblers work and stuff like that.
Yeah. This is also with the lifter.
Yeah. So what I thought was really cool about this is not only is it open source, but the license is the Apache 2 license, which is, it's a decently open license. You can use it for commercial use, you can modify it, distribute it. You just have to note like state changes, disclose like copyright and license and stuff like that. Um, But yeah, I took a quick look at the code of some of the plugins that are in there, and they are absolutely insane. You're talking like 8,000, 9,000 lines of code for like the disassembly stuff. Um, it is coupled to Binary Ninja's API, which is probably worth noting. I don't know how easy it would be to decouple from that, but this is something that I think would be cool that you could borrow code from or reference it to if you wanted to build your own tools that require similar capabilities that this facilitates.
Well, I think the big thing that Binary Ninja is probably hoping for here is that people start adding on to it and instrumenting instructions that they haven't yet done. I have to feel like that's a big reason why they'd go open source with it, is to provide that. And I guess they have already, like the PVC architecture was already open source. But I have to feel like that's why they're opening it up, is in the hope that people will add on to it without them needing to do the actual work on that.
Yeah. One thing that's cool that I actually just noticed, somehow I skipped it in my original reading, was it seems there's going to be more architectures that are open sourced over the next couple of weeks. They mentioned x86, x64, and MIPS. So, even more to look forward to on that front, which is pretty cool. I'm not too surprised they're doing x64, like x86 and x64, because that stuff it is so hard to lift on x86 because of all the extensions and stuff like that. They actually have an issue with a table of like all the extensions that they need support for, and the scroll bar on that page is like the smallest it can get.
Well, I mean,
So
there's a lot of instructions.
yeah. So yeah, I think it's a cool move both on Binary Ninja's part if it can help them out, but I think this could be interesting even to people who want to build their own tools and just want like a reference point or something like that, right?
Yeah,
And
I don't know how useful it's going to be for that, just because, as you've noted, there's a lot of tie-ins with Binja. I mean, it might be useful on that.
yeah, you'd have to look at how easy it'd be to decouple it. I didn't read the source thoroughly enough to be able to comment on that too heavily. So this is another example of where Vector 35 is involved in the community and likes to contribute to it, which, unlike a certain other vendor who writes disassembler and decompiler tooling, this just kind of shows that that good faith and willingness to work with the community. So um, really wanted to
I
shout it
don't know.
out.
I mean, you can definitely take that more cynical view on it. Like I said, rather than wanting to work with the community and with the community, just wanting the community to do the work for them.
I sup- mm,
That's kind of what I was getting at, mentioning there. Like, why
I
are they open
s-
sourcing? It could be over that. And to be clear, like, I like Binja. I'm not trying to hate on them. I'm just, that is the more cynical view here.
Yeah. Though that's definitely not like a view that I'd hold. I think maybe there is a bit of a hope for that, and that is like the power of open source, right? Like I don't blame them for doing that, but
No, and there's definitely some benefits to the community that they're doing that. Obviously, the community can get involved if there's some odd instruction that they're probably not going to get to. You're able to kind of jump in there, do it yourself. It is a place where if you want to get involved with the community, there's a launching place. There's work that needs to be done. I'm sure we missed this though. A Seferini, I'm not sure how the name said. Thank you for the 133 bits.
yeah, awesome, thank you. So our last news topic is a bit of a more questionable one. Just thought it would make an interesting discussion on whether it's worth the effort. But it's a memory safe curl for a more secure internet. And what they're talking about here is building a Rust backend for TLS for curl. And I saw this kind of circling around in like discords and stuff like that, and people were saying like, did I miss something? Is curl really, are there like tons of people that are getting popped through curl or something? um
I don't think so, but at the same time, if you think about what's an application, what's a library that is widely used and definitely has the potential for those types of issues. And actually, I should mention what they're working on is adding support for Hyper. So Hyper is a Rust-based library for HTTP stuff that already exists. and Rust would just be using that as a backend rather than some of the other options. There's a little bit more information, like architecture wise, in the post from or on the curl website itself. Includes kind of some architecture and how this kind of plugs in there, and where there's still going to be C, and basically just curl as a big glue code to get it over to a backend library, in this case support for Hyper. But when it comes to the question of is curl getting popped, maybe not, but at the same time, imagine you had a vulnerability when somebody requested a page via curl that you could pop the server making that request. Curl is used in so many different places behind the scenes that you don't really notice. It's basically the default. If you're going to do any web requests with PHP would be an obvious case. Libcurl's usually what ends up getting used. I think you do have some other options now, but and obviously any just scripting in general, people might call out just use curl or wget, but curl is one of those major options. So with so many applications using it, there's a lot of room for curl to be pwned.
Yeah, that's a good point that I hadn't really thought of, was the the point of libraries using curl. So yeah, that's good that you brought that up. But yeah, it does. I think part of the reason this was memed on was because of the classic, Rust equals more secure. But
yeah, I mean, they're not like, this isn't a rewrite of curl in Rust.
No.
They're using it. It'll be a backend that you can use, not necessarily the only backend.
Yeah. But yeah, overall, I think it is a good move. Like it's definitely a positive move. Like it doesn't really have any drawbacks. It's just
It's
people were
also just
questioning, is it
support,
worth the effort? But
like, he's getting sponsored to do that. It's support for curl, which I have to assume curl needs it.
yeah, probably.
I mean, if somebody wants to pay for that, by all means. I mean,
By all means, yeah.
Yeah.
All right. So Apple. So this was the big news story of the week. This article was titled "We Hacked Apple for 3 months. Here's what we found." And this is a bunch of exploits all collated into one article. So so this accounts for all the findings from this group of researchers who did an engagement for the Apple Bug Bounty program. They participated they operated on it from July 6th to October 6th. They found 55 vulnerabilities, 11 of which were critical, 29 were high, and 15 were medium and low. So obviously, we're not going to go into all 55 vulnerabilities because we'd be here until next Monday.
And they don't write up all of them, so
yeah, exactly.
We don't have all the information either. I will mention, I did think it was interesting their approach here was just because the Apple Bug Bounty doesn't really list the websites and all of that as in scope. It's mostly focused on their hardware devices. But they will pay out for significant findings that impact users, and thus they decide to go look at all the web applications and stuff anyhow. And I mean, they go into a lot of detail. Like Spectre said, we're not going to run through everything. Up front, I think it was about $280 some $1,000 that they've been paid out so far, and yeah, $288,500.
Yeah, so that was over the course of 32 payments, and they did say that there could be more coming because Apple typically does their payments in batches, so that might not even be the final amount for all their findings. Just wanted to throw that in there.
Yeah, that's what I was kind of saying. That's how much they've gotten so far. I do think there are a couple of takeaways from it. You can kind of dig into the actual reports if you want. I mean, these are fairly well-known researchers, good reports. I won't spoil all of them here. That said, you do kind of get an idea that at least one of the common tactics of just looking for the things that are going to be overlooked comes into play here. Like, they have a full compromise on the Apple Distinguished Educators program. I'm not sure about you, Spectre, but I've never heard of that program. It feels like one of those things that could easily be overlooked. It's just like, okay, they have it, but whatever. And I mean, a big part of their process here is the automation, is that automated scanning to find all of the endpoints across this entire network. But looking at some of the issues they found, there are a lot of things that just seem like they're little hidden away things, which, as usual, is just kind of one of those pieces of advice when it comes to the bug bounties, is looking for the things other people will have missed.
Yeah, I was just gonna say I hadn't heard of that program either. When I looked at that, it felt like something that I should have heard about, but I just didn't. So I don't know if it was something that Apple was hoping would get bigger and just didn't, so they just leave it running. But yeah, I don't know. It was weird. Like you were saying though, like those types of areas are definitely really good places to look for issues. Um, Now, some of these issues were like had pretty incredible impact. For example, there was a server-side request forgery in iCloud, which allowed the retrieval of Apple source code. There was another blind XSS, which allowed access to internal support portals for customer and employee issues. Some of these issues were so severe that I saw some people saying, even one or two of these issues would probably be worth $280,000. Never mind a collation of like 11 of them or 12 of them or however many of them they've been paid for so far.
To who,
So,
though?
well,
That's
yeah, I
always the
guess in gray
problem when,
market would probably be where they would be worth that
well,
much.
the gray market generally isn't going to buy them because these are things that can kind of be centrally patched. Black market, sure.
Hmm.
Gray market's a little bit harder of a sell for a lot of these things. I don't know. I feel like a lot of people like to speculate, like they see one issue that compromises a bunch of users or something like that, and then they go, "Oh well, big company, therefore somebody's willing to pay millions for this, or hundreds of thousands." And it's fair. There may be somebody. Apple's a large enough platform that there's definitely going to be some interest in that. But usually people are going to want kind of their money's worth out of it. So that's where you attack the hardware. You're able to focus on a specific individual, and you kind of get access to everything, like on their phone, for example, if you're attacking the phone. When it comes to the applications, like, okay, so you can get access to just their iCloud. Still useful, or email would be another case. You get access to their email. That's still absolutely useful. Uh, but the level of persistence that you have is kind of lacking. And then you're also facing, like, as soon as that's patched, there's no tail to the vulnerability. When it's something like these web things, like they get patched, it's patched for absolutely everyone everywhere.
It's
Well,
hot fixed. Yeah.
yeah. So that kind of drives the value of them down. Again, I'm not saying like there would be no buyer, but just
Yeah,
saying like trying to sell it would be difficult.
and the other point on that is just because, you think a vulnerability might be worth that to some people doesn't mean that's what, the vendors should pay out. I don't think that's a, reasonable it shouldn't be one to one with what you would expect other people to pay for. That just doesn't really make sense. Um but yeah, I mean this is kind of cool because they do give credit to Apple. They said that Apple was very responsive and had a quick turnaround. They usually fix issues within 4 hours. Um, but it's worth noting that Apple, like, they allowed them to publish this. Like, they didn't publish this without like Apple's consent or anything like that. So I feel like that is cool on Apple because some of these issues probably look bad against them, and because Apple's always had that security aspect pretty firm in their marketing. So it would probably be in their best interest to shut a report like this down as a condition for paying out. Kind of like an NDA. If we pay you out for this bug, then you don't talk about it ever. But that's not what they did here. So I think Apple does deserve a bit of credit for that.
No, and I mean that's generally going to be a good sign with a company, is not trying to silence vulnerability reports, because these types of reports are how people can kind of go and see, and like, even Apple has made some mistakes. It's how they respond to it that I think matters more. In
Yeah,
this
that's
case,
kind of
like,
the
researchers
theme.
can go ahead and learn from these vulnerabilities. One, define them themselves, and two, if you're kind of more on the engineering side, fixing them and what not to do in your development or things to consider. Kind of the publicizing of reports, I think, is an important part of that.
Yeah. So overall, if you're interested in the technical details, you can go to the article that we'll have in the description in the YouTube VOD. This is a extremely long article. This is probably the longest article we've covered on the podcast. Like this could literally be a white paper in and of itself. So, you'll have to kind of go through and look at what you want to look at unless you want to read the entire thing, which will probably take you a while. But yeah, those are there if you want to check out more of the technical details. So, some HackerOne bounties. Mostly getting into the Love React and community files. This is a race condition found in Figma. So Figma is like, it seems to be like a vector graphics editor, and it was a race condition in the karma system in the community pages. So you could like and unlike posts and remove a like that you already gave. Basically, problem comes in when you can send requests in parallel. You can cause it to unlike more than it should. And it sounds a lot like some of the issues that we covered before with like CTF platforms. We talked about the CTF platform that had an issue. If you submitted flags in parallel, you could get more points than you otherwise would be able to get. Very similar in concept to that, I think.
Yeah, this is a fairly straightforward race condition. You have an event that should only happen once. You send the request multiple times. Multiple threads kind of make it through that gate and perform the action multiple times. I just thought, it's fun seeing them. I like race conditions on the web.
Yeah, it's something you don't get to see super often. So
Yeah, I mean, they're definitely out there, and this is very kind of low impact. Like, okay, you can, do 100 dislikes on whatever. It's, that sucks for whoever's the recipient of it.
you can ruin somebody's day.
But yeah, it's not that huge of a deal, and this was just $150 bounty. But
Yeah.
it was a bounty, and I don't know, race conditions are one of my favorite things to go and test for. Because, I don't know, it's kind of one of those fun issues on the web. It's, in a sense, you don't really expect it. And then, you just get it, and you're able to kind of push the limits a bit.
Yeah, that's what I was kind of thinking too, is that it seems like something that's very easy to overlook when you're designing a web application. What I found interesting in the report here was this issue was actually fixed internally, um, and it just wasn't pushed to production yet. But in good faith to the researcher and to encourage high quality reports, they still paid out, even though they internally fixed it independently on their own.
Well, they say they internally fixed it beforehand.
Yeah. I'll take them at their word.
Yeah, no, I can give them the benefit of the doubt on that.
Yeah.
It's definitely possible. It is one of those issues that, it's easy enough to fix, so they could have had it. They could have seen it already, or especially if in testing they would have tried to abuse it a little bit, it could have been picked up pretty quickly. Like, oh, this account suddenly is in the negative likes. Like, that can't happen. Something like that could have just brought their attention to it and led to it getting fixed before they actually made the report.
Yeah. One thing I did find a little bit weird was they said they like to encourage high quality reports. But kind of like Valve, this report is limited disclosure. So there's a summary, but there's no report, there's no comments. I do kind of wish we got to see the original report, because if they want to encourage high quality reports, then one of the ways you can do that is by showing off what a high quality report looks like and what you're looking for. So that was something that I kind of wish they allowed us to see, but obviously that's their prerogative if they don't want the report and time and full timeline and stuff disclosed. But yeah, that was just like a tiny personal gripe that I had with it.
Yeah, so did you take a look if Figma does that for all of their disclosures? They just do a summary?
I think I meant to, but I forgot to. Yeah, because I see why you're asking that, because Valve does that with all of their reports.
I'm just pulling them up here to see. I see a lot of just non-disclosed reports here.
Yeah, so they just don't
Actually,
like going
this
open,
looks
I
like
guess.
it's the only disclosed report.
Well, I guess that's better than the past reports, so fair enough.
Yeah, more information.
Yeah. So Project Zero, they did a post on HashiCorp Vault, which I think we might have talked about before in passing. HashiCorp Vault basically allows you to set up a vault of secrets for generating and access secrets, so like passwords, certificates, keys, like API keys, stuff like that. But where it really shines is the API integration with cloud-based services like Amazon Web Services and Google Cloud Platform. So this post talks about two authentication-based vulnerabilities um, through that integration, one via AWS and the other one through GCP. So AWS, they provide two methods of authentication. They provide identity access management and EC2, which is their elastic cloud compute. Um, P0 tunnels in on IAM, which I think we've also talked about before. It basically allows for IAM users in AWS or roles to map with Vault roles. And then a policy can be assigned to that mapping to allow access to whatever secret is needed for that type of authentication. So they go into detail about how that works using, the security token service and the get caller identity API function. The issue boils down to the fact that they allow pre-signed HTTP requests using that get caller identity endpoint to go through the Vault server, and then they forward that on to the STS to get the result. But
So
they
I'm
don't validate all the stuff going to it.
okay, fair
I'll
enough.
let you jump in there.
Yeah, sorry, I started mentioning and then you kept going. I was going to say I don't think like the issue. I don't think it actually stems out of the fact that they take a pre-signed request. That's kind of a pretty standard way to go about it. It's signed, so in theory, whoever you're giving it to make that request. So the idea with signing it is you generate kind of the request to the AWS API, which requires that you sign your request using like your service account, using your account, whatever. You sign it using your key. And that way, nobody's able to tamper with it. And that's how it kind of authenticates that it came from whoever it's supposed to have come from. So with Vault, what it does to kind of authenticate you. So when you make an authentication request with the Vault of this IAM type, what it will do is it'll make a further request over to get the security token service, the get caller identity. You give it the request that's going to make there, but it's the Vault service actually making the request to that API. And as you can guess by the name, it's just get whoever, wrote the request, get whoever signed the request. Whoever's making this request, what's their information? That way the Vault's able to get that, but it's getting it directly from AWS. It's not going to trust anybody else. So you give it a signed request. So you pre-create the request that you want. And then the Vault will take that request and actually send it over. So the issue here, I guess, as Spectre was going to get into before I end up interrupting him thinking he was going elsewhere, is that they don't do enough validation on the actual content of that signed request. It does hard code the fact that it's going to the STS server. Like it always starts with that HTTPS sts.amazonaws.com. Always starts there. So one of the obvious things, or one of the obvious attack points, is if you could control where the request goes. If you can get it going to another web server, you can control the response that it sees. You control the response that it sees, you control who the Vault thinks that you're authenticated as. Fortunately, most of the obvious attacks weren't really working with that, or couldn't really work with that. Like I said, you could try compromising kind of the building of the target URL, but Golang itself has a reasonably robust kind of URL parser that largely stops a lot of those tricks. The user does control all of the headers. So what the user controls, I believe, is the header, the URL parameters, post body. I think that's all. There might have been one other thing in there that you can say that the attacker controlled. But what they didn't control, as I already mentioned, they didn't control the first part of the domain, just everything kind of afterwards. So controlling the host header, if they did some host-based routing, could have been another option that Project Zero did explore. STS doesn't do that, so no luck there. And the whole report goes into a lot more detail than I think we're going to. But what they ended up finding was that the vault will decode whatever response it gets just using the standard Golang XML decoder. Or I guess I think it's technically in the encode library, but it's doing the decoding there. And an interesting, not necessarily a quirk of that, but it'll look for the start of the XML and the end, and it'll ignore all other characters, which allows you to kind of put your XML just randomly in the middle of the actual request data. So kind of the attack route that they went for here was to find some field within the STS API that they could control and place this XML response in that actually contained, whatever arbitrary user they wanted. So what they figured out was that even though the AWS will by default respond with XML, you can, using a URL parameter, tell it, or it's not URL parameter, sorry, the header, you send it the content type headers application JSON, it'll respond with JSON. So what they found was there was one field that they figured out, dug through there, subject from web identity token, which they could inject XML into. Of course, the downside of that is that comes from doing like a JWT authentication, using like an OpenID or OIDC connect. I guess I said connect twice with that, but they basically inject the XML into that field so that the prepared request that they send just kind of has the XML in the middle of the response. I think they kind of show an example of that here. I'm just not, there we go. So we'll see just where it parses out the subject from web identity token, it has that XML. So this end up, they need to create like their own OpenID Connect provider in order to get something to sign a JWT for that, and they kind of talk through the process of that. But I thought the idea here was kind of cool too. Basically inject that into a into a trusted API, and just taking advantage of the fact that it doesn't check that the entire response is well formatted.
Yeah, which do you think that is an issue that Go XML decoder has, that it doesn't reject non-XML content? Or is that just an issue of not using it correctly? I'm leaning probably towards the latter, but I'm just kind of curious where you would come down on that.
That's a good question. I hadn't really thought about it. I think it could go either way. I mean, you could always just have a flag there to enable like a strict mode to require that it only be passed in well-formed XML. I think there's so many cases where you just can't necessarily guarantee you're going to have well-formed XML, where the XML parser really should still work.
So what's interesting is I'm looking at the XML decoding package for Golang, and they actually do have a strict mode that states if it's set to true, or if strict mode is set to false, it allows unknown or malformed character entities are left alone and stuff like that. So maybe they disabled strict mode explicitly.
Well,
so
that might also just
be
that might also just be for inside of the XML.
Yeah, it's not totally clear. I just took a quick look because I wanted to see if that was the case, but yeah, it's not really clear on if that means they reject non-XML content entirely.
Yeah, I wouldn't necessarily push it as something that is the fault of Google or Golang for not doing that by default. I think there's fair reason to go both ways.
Yeah. So this issue is kind of two issues in a way, right? Because there's the XML decoding issue that you went through where it won't reject non-XML content. but also the problem where they don't restrict the query parameter on the HTTP request. So that allows them to access any action in the STS API, not just get caller identity. So I think that's where they mostly focus the fix on the issue. Was they now have an allow list on the headers and restrict requests to get caller identity. And what I assume they mean by that is, making it so you can't just call any action you want. They actually check the query and stuff like that now.
Yeah, which makes sense. I mean, that is, as you said, kind of the root of the issue is the fact that it was just so open for users to craft effectively any query they want. And that is problematic when they only actually expect you to go to the one. It is worth noting they do go through a Google Cloud platform. It goes through a different attack. But they do find another way into the vaults through or on Google Cloud.
It's kind of like I don't know if like a confusion is the right word, but basically, as I understood it, the problem was the JWT tokens were processed in the same path between IAM and GCE authentication methods. And because of that, if you used IAM, you could actually spoof GCE claims, which basically allowed you to fool it into thinking you were using GCE when you weren't.
Yeah,
Um,
so kind of expanding there, the one thing that would happen is when you had with the Google Cloud variant of the attack, you would provide the JWT. That JWT should be signed, and it would check in doing the validation. If you're getting this from GCE, it would be signed by it would be signed by a Google owned cert, and it would contain a. Actually, I guess before I kind of go into that, either you would have it as like your accounts token, or you would have it as a GC, so your compute engine, like your virtual machine server, would have the credentials. So that just comes down to the different permission structure with IAM, how you can have the resource permissions. We were kind of talking about that last stream, actually. Kind of comes down to that. So with the GC ones, it's signed by Google, and it contains this claim inside of it, a compute engine claim, which has further details about the process, about who owns it, the instance name, project information, zone, kind of all the metadata about the GC instance. And as Spectre was saying there, it would do its validation by checking if the key was valid. So just look, is this a Google signed key? And look for, if any of the Google keys match it. Or if it fails that, it would pull out the email address that of the account that signed it and pull that account's key and then compare and see if it was signed correctly. But it didn't separate the logic. It would do both of those in just the one run. So if you created your own signed key, but included that compute engine, it would just trust your compute engine. Or if you included that compute engine claim, it would just trust that you were actually a compute engine, even though it wasn't signed by a Google key. And that way you're able to provide whatever user information you want from there.
So these issues went into more of the, logical style authentication flaws rather than, some of the stuff we usually see from like P0, like memory corruption and stuff like that. And this post is just kind of a point in favor of that fact that just because your code is written in like a memory safe language like Go in this instance or Rust or whatever, that doesn't mean your code is secure. You can still write code incorrectly even if it is memory safe. And these are some of those issues that you need an intricate understanding of the system and how it works to be able to spot and correct these issues. The author of the post actually put that directly in there for both of them, I think, saying, this is very easy to overlook and kind of being charitable to, the code authors. Because it's just these systems do get pretty complex under the hood, and small mistakes can have a large impact. And their quote in the conclusion is like perfect, I think, like a perfect endpoint. Finally, both discuss vulnerabilities, demonstrate how difficult it is to write secure software. Even with memory-safe languages, strong crypto primitives, static analysis, and large fuzzing infrastructure, some issues can only be discovered by manual code review and an attacker mindset. I mean, that's another thing that's worth noting here is something like a fuzzer probably wouldn't catch this issue because of how involved and how quiet it is, I guess. Like it doesn't, it's not noisy, it's not a crash or something like that. So this is just testament that manual code review should never be thrown out entirely. So yeah,
I mean,
there's a few like key insights out of this post, in my opinion.
there's that manual code review shouldn't be thrown out. I think there's also just the aspect that this is kind of where application security is moving towards, are these sorts of higher level issues rather than the binary stuff. As we talk about, as we were talking earlier about shadow stack, about things that kind of make the exploits more difficult, these issues are still there and still aren't being found easily, um, and really just require a lot of that heavy lifting. So, I mean, as time goes on, that's kind of the area, being able to analyze the source code at a high level and kind of pull out what its issues are. Is kind of where the job is moving towards.
Yeah, I think part of the reason why binary is so much, more explored, I guess, than these kinds of issues is these kinds of issues just aren't really as sexy. They require more of a, intimate understanding of what's going on to even understand the attack very well. Whereas with memory corruption, it's a lot more, interesting and exciting. So I think that's, and that's kind of unfortunate that I think you're right. Like the industry is going to move towards that, and binary stuff is going to slowly die over time, which is really sad. But I don't think you're wrong there. So keeping on the role of cloud, we have something affecting Microsoft Azure as well. So this is called "Could I Enter Your Server?" So it talks about vulnerabilities in the Azure App Services, specifically in the Kudo Lite component, which I believe is used for Linux, and that's where the "could" play on words in the title comes from. It's basically an administration panel that you interact with over HTTP. It allows you to get diagnostic information, Docker logs, as well as a limited shell, which can only interact with the home directory. So this is actually two issues that run in a chain. The second bug is used to be able to exploit the first bug. I feel like they probably should have reordered for that reason, because I'm actually going to talk about the second bug first, since you kind of need that as your first stage. So the second bug is in the API. So the API is accessible from the application node without requiring any validation. So any SSRF can allow someone who abuses that API to steal source code with GET requests or get remote code execution via POST requests. So this first bug, it allows them to escalate to root due to usage of hard-coded credentials. So they first discovered it in the application node's SSH service, which wasn't too much of an issue because the application node SSH port isn't accessible from the internet, but the same credentials are also used in the Kudo Lite SSH instance. Now, something important to note there is the fact that you would need another, SSRF vulnerability in this chain to really go from unprivileged to root. But yeah, just another multi-stage attack, which is always fun to see.
Well, to go from unprivileged to root, I mean, you're able to use that command API that they use for the code execution, and that is your way of then calling SSH, to basically open up another connection and use the default, or well, I guess not default, use the hard-coded credentials. So you wouldn't necessarily need anything further for that. You can exploit the first issue through the second issue. Because
that's what I mean. To exploit the second issue, you would need that SSRF. They leave that as like a do-it-yourself.
I thought you meant you need to get a further one. Sorry.
Yeah, no worries. So yeah, that is another multi-stage attack. They reached out to Microsoft, got the issues fixed. My thoughts on it, they kind of mentioned this in the article, but this kind of demonstrates how cloud security does still lack that maturity of some of the other areas. So it's always worth shouting out those types of posts. It's kind of similar to the P01 in the fact that it's another one of those higher level issues that can just, easily be overlooked and can have a, big impact.
Yeah, I mean, you're definitely like the attack surface is limited. You need so this is with the was Azure App Service, is that what it was called?
Yeah, Kudo Light.
Yeah. Well, so Kudo Light's what they deploy in, but it's Azure App Service. So you need a vulnerability in whatever app is being deployed through Azure App Service. That's where the SSRF comes from. So that's going to depend on, so Azure App Service is kind of your platform as a service from Azure, where you've got a web app, you can just kind of put it on there and they deal with all the hardware, all the infrastructure. So you would need an SSRF in that. And I mean, SSRF, it's not unheard of, it's not uncommon, but it's not terribly common either. So, like, you do need to be running some vulnerable code already. That's where your SSRF is coming from. So, definitely kind of a limited access. And I feel like when you're kind of behind the scenes like that, developers making some of those choices, like the weak password, just kind of reusing, what's easy. You definitely see it a lot, and that's kind of been one of those things that'll bite people in the ass, is when they end up doing that and then somebody just breaks the perimeter and suddenly everything's just soft targets.
It's kind of like that old mantra of putting all your eggs in one basket, and how that can screw you over. So NordVPN is back in our set of topics. So the NordVPN web app leaks a password reset token in the HTTP refer header to third-party sites, which we've talked about some issues that are based around this before. If a password reset token can be retrieved by an attacker, they can use that to perform account takeovers. So nothing super like novel or interesting there. I think we saw that issue with GitLab, I want to say. I think had it like a similar report we covered recently.
No, I don't think we've talked really about third-party information disclosure on any of our
Oh, okay.
episodes.
Maybe
We have
conflating with something
talked
else.
about things that expose the token, as you're saying. Like there have been a few cases where applications have included the token in like the response and just not shown it to the user. I believe GitLab might have been doing that.
Yeah, I think that's what I was thinking of.
So in this case, what happens is if you do it, and this is where you'll kind of see it. They got a $600 bounty. It's a specialized circumstance, but in this case, after you do your password reset, so you get the link in your email, you click the link or otherwise visit it. And if on that page you then click like the Facebook social media button and like go to Facebook from that page without actually doing your password reset, Facebook will get your token. So like the risk there is kind of low. I doubt Facebook is really trolling for NordVPN password reset tokens. I doubt a lot of people are clicking go to Facebook from their password reset and not also actually doing the password reset. So definitely kind of a low risk in this particular case. But third-party information disclosure, I do think, is another one of those, kind of things to pay attention for. They don't happen a lot, but they happen in some unexpected ways. In this case, it's that header, that refer header. So you click the link and like, hey, I'm coming, from this website, unless you have like tracker blocking stuff on your browser, which can prevent some of that. Your browser doesn't know what information is sensitive or not in the query. So it's just like, here's where I'm coming from. So in this case, like I said, Facebook probably isn't, looking for these. Probably, like, there's probably nobody at Facebook that was actually actively looking for any of these tokens coming in, like abusing that. But there are other. Go ahead.
Well, I was just gonna say, which is why I am surprised that it paid out as much as it did. Because like you were saying, this does have a low impact severity, which NordVPN usually pays out $100 for as a tier. And high impact is $500. Yet this got $600. So this is paying more than a high impact rating on their page, but it's it's being sent to like Facebook and Twitter. You don't control where it goes. Like, I'm just really surprised how much this paid out. It seems like they overpaid. I don't know if you'd agree with that, but yeah,
No,
just kind of
I would
my own
agree
personal
with
take.
that. Yeah. Especially since you pointed out I didn't look at what their usual payment was. Um, I mean, I guess because it does provide the potential for an account takeover. Like, I could understand why they might put it a little bit higher, just because of the fact that yes, it's unlikely Facebook's doing that, but this is a vulnerability that can lead to that. Therefore, you know, treat it somewhat higher. Like, I could understand the logic going both ways on it. I just
Yeah,
wanted to kind of call it out though, as just one of those issues where, in this case, it's a social button. Other cases though, especially like really any sort of link on a page for the refer header can end up leaking that. So if you have the right page to where you control a link on it, that's one of those places where you can kind of find this. Like I said, it's one of those things. There's not a lot of situations where it hits, but when it hits, you can. It's usually something interesting.
so the timeline I found pretty interesting. It was reported 10 months ago on December 4th, and it was fixed pretty quickly within 2 days. But what I found weird was there was a lot of comments after it was marked as resolved, and there were like 2 or 3 changes to the severity as well throughout the timeline. So like the severity was changed like at the time of the report and when it was fixed at December 6th, and then it was changed again. Um, I think in September, like last month. So it's kind of weird seeing the severity change like 10 months after the issue's been fixed. Which does kind of make me think that maybe there was a bit of a dispute or discussion around the severity it should have gotten assigned and stuff like that. But obviously we can only really infer that from, the existence of the changes because we can't actually see the comments because they're hidden. So
Yeah, I mean, it seems like they paid out the bounty though pretty early. So, I mean, the debate over the severity. I mean, at
yeah,
that point, it's just nitpicking. Like, it's already been fixed. You've already been paid out for it. You're not going to get paid out more for it. So kind of going, yeah. Now I didn't notice that, but now that you mentioned, I'd be interested to know kind of what that discussion was.
if I had to guess, the initial severity rating might have been high because that would fit in the $500 to $1,000 range. And then the severity was just lowered later on after it was already paid out. So that might be why there's a discrepancy
Might
between
have
the
been Nord
payout
asking
and
for their money
severity.
back.
Could have been. Never know. Unfortunately, we never will. So, sea surfing Google. So this is called the mass sea surfing of google.com products, and it abuses the content sniffing algorithms of browsers like IE. So if you append the semicolon evil.pdf to the URL as the example they give, you can force that page to be loaded as an application slash PDF even if it wasn't. So faking the file extension basically. Um, so they talk about how like Adobe validates PDFs by just looking for the file magic, the percent PDF1, and then just keeps on reading it as long as the structure is right. Um, I think the key to this issue is the fact that websites and Google services in this particular case allow the attacker to inject, special characters into the URL, like that semicolon in the .pdf extension. Um,
Well, that's less about the user injecting that, and yeah, like the user controls the URL they're requesting. Like, that's not something that's
Yeah, I think
like
the issue is
how
being able to
would.
upload a file that would be read as a PDF with by being able to control that name, even if it's not necessarily a PDF. I
Well,
think
yeah.
that's where they were
So,
going with it there.
oh, well, so what I'm saying though is like I don't think the control of the URL is an issue. The issue is definitely being able to inject the binary data where it shouldn't be a binary data, and the issue is the fact that IE will. They don't mention it here, but I have to assume because pretty much everything on Google does use the no sniff header that at least that's present. Or possibly that's actually kind of been retired now. For some reason, I'm thinking it's retired, but I'm actually just going to pull that up quickly, but it does feel a little bit like this is more of IE's issue than Google's problem. And I guess I will mention part of the thing here is with PDFs, you have this form calc function within them that you could basically use to make get and post and push requests through the browser that you're viewing in. So it'll send the cookies and stuff, so you can go ahead and make a get request, read the page content, and from there, see whatever the CSRF token is, and post that away to your own website for you to exfiltrate and do whatever you want with that token. Or, you can make further requests. So part of the issue is just PDFs are stupidly powerful. And to be fair, you can't just do any website. So like with Flash, you do need that cross-domain.xml file to go cross-domain. In this case, though, if you're able to find any endpoint on Google where you can get the PDF content in, then you're able to still make the request against any like google.com or anything that doesn't violate the same origin policy. So that's where they're able to CSRF like all of the Google tokens. That said, when, jumping back to what you're getting on with Spectre is being able to inject all of the binary data. Sometimes that's just unavoidable. You don't control what type data users are going to have.
Yeah.
Like you need to be able to support Unicode names or whatever. How long is too long for a name? I mean, your PDF file might be a little bit long for just somebody's first name or something, but it's a hard problem. So, I mean, the one place that this can be stopped, and it would only seem to be Internet Explorer that actually had this particular issue. It does feel a little bit like it could be Internet Explorer's fault rather than calling this a Google problem. I would be curious to know kind of what the fix was on this, if it was just preventing. So I guess if you just prevented the PDF, like the magic number there, if you prevented that, that could work, but that feels like a real kind of band-aid hack sort of solution.
What I was thinking was they fixed the trick of appending the .pdf extension to the URL to avoid the IE issue. But that was just my guess, because that was something I was thinking here too, was like, I wish we had some information about the fix. And to be fair, like maybe Google didn't provide that. I mean, they don't have to. But like, yeah, it does leave you kind of guessing as to how they would have fixed this, because I was of the same opinion. This seems to be more of IE's issue than Google's. So,
I mean, I guess if they got a request that ended with PDF when it shouldn't, they can take note of that and just not serve the content. Is that kind of what you're thinking of?
That's what I was kind of thinking, yeah. Because like the example they gave was the Google Contacts, where you could upload a CSV or like import and export CSVs. And what I was thinking was, they would either take the file name if it had like .pdf at the end of it or had that sequence of characters, they would just reject it. Or looking for the magic number, like you were kind of saying there. But yeah, I mean, it seems like kind of a weird problem to solve from Google's side, which is why I really wish we got more of the fix information.
Yeah, I'd actually say, like, yeah, just looking for that PDF in the URL and not serving, if you saw that, feels like a better solution than trying to prevent the %PDF-1. Especially because, like, that's a completely ASCII magic number. Like, it's not even binary at all. So there could be accidental hits on that.
So
still wouldn't be common, but it could be.
So the payout was interesting. They list the rewards for this issue as $30,000, which that's cool that Google gave them that. But I am surprised because this issue only affects IE, and IE has a very low market share nowadays in the areas of browsers. When I was looking it up, I saw like I think 1.3% is IE. Right? It's just it's such a dead browser, especially where Edge has now replaced it. So I am surprised Google paid out as much as they did, considering it's more of an IE issue than it is Google's, at least from what I can see. But if Google wants to pay that, then that's good for the researcher, I guess.
Yeah, and I guess in fairness, we have seen, I think, some cross-site scriptings that have only impacted like one browser. I think usually that ends up being Chrome, but just because that happens to be where people look.
Yeah.
So
Yeah,
I
we
mean,
actually have an issue kind of like that later on.
it is a leak of the CSRF tokens. Like it is kind of valid in that sense. So, oh no, I think Google's definitely a little bit more willing to just pay out, kind of keep the goodwill of the researchers. And that could be what's going on here.
Yeah, I could see that. Yeah. Overall, though, I mean, it is a bit interesting, and like you said, it does raise that awareness. Um, you know, when it comes to PDFs and how stupidly powerful they are. Because I don't think people realize like how much PDFs can actually do. It's pretty incredible. So
Actually, I didn't even realize you can do this with them, if I'm being honest there. I remember I used to do some CSRF stuff with Flash, which is a little bit more obvious that it's stupidly powerful. Of course, now most
now
things
it's
don't
not.
support, but once
Yeah,
upon a time it was.
once upon a time. So, moving into a possible 0-day story. This is a story about Leostream Connect Broker. So, this was a cross-site scripting that led to RCE and Leostream, which is a platform for managing connections between cloud desktops and virtual desktops and whatnot. Um, and this was
Yeah,
kind of
you
an interesting
can.
story.
Sorry, you can kind of think of it like a security wrapper around your virtual around like virtual desktops and stuff. So it's got a use for like the enterprise clients actually, especially now with the virus going around. You've definitely got the case of more people needing to connect to like in-house infrastructure remotely. That's where this is going to be used.
Yeah. So this was kind of an interesting story because it appears this platform is old or just somebody really loves Perl still. And not only was it written in Perl, but it also used encrypted Perl using something called source filter, which I'd never heard of before. I guess it was probably before my time. But yeah, they walked through how they broke the encryption, which was doable because they had full access to the VM. They were root. So it was just a matter of like observing what was happening in memory and finding the initialization value and stuff like that. Um, but after they got the real source files, they did some manual code review, and they found that their sanitization for user controlled data into the database was literally just escaping single quotes to avoid SQL injection, which already is like super shady whenever you see some of those kinds of custom weird filtering instead of using something more robust like prepared statements or something like that. It's likely to be implemented badly. So here they don't even try to sanitize against other types of special characters that could be used for things like HTML. So that's where the stored XSS comes into play there. So they said they found this pattern in multiple areas, but the one they tunneled in on was user agent tracking. So the user agent string isn't sanitized, and that's a problem because that's actually provided by a browser. And if you have a malicious browser or a malicious browser extension or something that's providing a user agent with a malicious payload in it, that can get injected, stored, and injected into the admin log viewing page. So whenever an admin goes to that page, that payload gets ran, which can allow compromise and eventually code execution by uploading a web shell. So they do mention some of the barriers they encountered when doing that. They had some anti-tamper measures against, abusing the, you know, injection. So I think they used like a digest to
Yeah, this
prevent requests from being made.
seems kind of like a anti-CSRF token is what they're doing
Yeah,
with the digest.
yeah. So it was that was kind of interesting. Which like I don't know if I've seen something we've covered that's done that before.
It's
Uh, th-
no, it's a unique technique for doing that.
yeah,
I mean, coming up with a random. So usually, like the traditional way of doing your CSRF tokens is that you'll generate a random string with ideally every form will have a unique and a token included with it. So then every time you perform an action, you end up with this unique token that needs to be validated. Realistically, there's a few shortcuts on that, like including is in the cookie, and then you need to include that value. You just need to make sure that like a remote attacker couldn't read it. JavaScript usually can. So like there's some well, not really hacks, they're valid techniques for CSRF tokens, but this one, it creates basically it hashes the URL that you're going to, your action, and along with a secret value, so it's not always the same, like so an attacker can't predict it. It's an interesting technique because that way nobody, or well, your attacker can't know what the URL is unless you've got cross-site scripting. So cross-site scripting generally is not, like, CSRF tokens do nothing for cross-site scripting. You can just read it, which is exactly what they do in this case. They read the URLs out, just right out of the DOM to get where to make each of these requests.
Yeah, and then they make those requests using like iframes, which, you know, iframes are another very powerful tool that I see used decently often when it comes to trying to do interesting things from an attacker point of view. But yeah, iframes
Yeah, I mean,
really
benefit here
powerful.
is, or one of the other challenges they had, I guess, for completeness sake, is to mention that they did also have to kind of make all of the requests in order. A lot of applications, you can just directly make your one request. Be like, I want to do this action and send that request, and everything's kind of stateless. This thing seems to track your state as you move around the application, so they did have to make several requests, which is where the iframes came in. You make your request targeting a specific iframe, then when that iframe finishes, you can make a request targeting the next. I mean, fairly standard way of going about this, from the XSS through to getting RC from it. You know, you have some sort of file upload not vulnerability, but some sort of file upload feature that gets abused by the XSS when an admin views it. Fairly traditional route, but unless you had more to say about the vulnerability, I think kind of the key thing is, as you were mentioning, possibly an O-Day situation, because the people running this just wouldn't respond to their support ticket where they tried to report the vulnerability because they didn't provide a customer license.
Truly awesome security stance.
Yeah, I mean, this sounds like he had accessed the program locally, so his testing was all done, you know, completely legally. He was running it on his own. He was testing something he was running, and wanted to report the vulnerability. And of course, as a company, they just don't have any sort of,
They don't have like a bounty or disclosure program or anything.
Disclosure program, yeah.
Yeah. Which is extremely weird, because you were kind of saying, you know, near the beginning that this is a product that kind of is designed around, you know, security around connections. So you would think, you know, a product that was targeting security would have something like a vuln research program or something.
Their team is too good to have vulnerabilities.
Right. Okay. Yeah. Fair enough. For me though, I think what was the most weird and unique part of this post was the encryption with the Perl stuff. That is just so weird to me, because if you want to, you know, provide a service and you don't want to provide the source for that service, then just why use Perl? It seems like an odd language choice to use for that. Now that could just be because it's old, and you know, when it was written, Perl was the hot thing back then. You know, I hope I don't get a bunch of Perl people coming at us in the comments saying, "Oh, how dare you say Perl is dead?" But yeah, I mean, I'm guessing that's what it is, because otherwise I have no idea why you would use Perl in this situation. But you know, that's just like my personal question.
I mean, would you use C? What are you thinking would be better?
C
I mean,
seems like an odd one to use, but
if you go with
maybe
Java or .NET, something that uses like bytecode, that's going to be quite trivial to reverse back to source also.
Yeah, but it's still it's something. And then even then, when you get to like Java and stuff like that, there are obfuscators already for that, which seems like it would make more sense to do than trying to do this weird encryption, which I guess is
But
technically a form of obfuscation, but
this isn't that kind of weird. I mean, it's, I guess, a source filter. So, like, the way they got around this was because they had access to a VM running and can inspect the memory of the process. That seems like about what you're going to get with a lot of obfuscation techniques, or a lot of other techniques also, is about the same difficulty.
yeah, it just
You're
seemed
not
odd to
really.
me. So
I think, like, especially if it is older, I don't actually know how old the platform is.
yeah, I
Um,
couldn't really find anything on that either.
yeah,
So
I didn't look into it at all.
yeah,
But I mean, if it is, and Pearl was kind of the hot thing, like, I don't really see a problem with that choice. I don't think it's worth it. Like, I don't think there's a ton of point in that. Like, there are definitely things they could do better for obfuscation.
yeah. So Portswigger is a site that we like to cover a decent bit on the podcast, and we have another post by them today. This one by Gareth Hayes, I think I'm saying that right. And this was inspired by the DOMPurify Bypass posted last month, which I thought we covered, but apparently we
No, we
didn't.
didn't. We
It must
covered a
have slipped
different
under the
DOM
radar.
Purify.
Yeah.
Well, DOM Purify Bypass. Actually, I think that was back
Was that before we went on
the
break?
break. Yeah, I think it was.
Yeah. Okay. So that original post in September was, about bypassing DOM Purify using HTML or mutation-based XSS. So HTML, they talk about how DOM Purify works and how it sanitizes HTML. Basically, it parses it into a DOM tree. It gets serialized by DOM Purify, and then it gets reparsed again by the browser. And the problem is there can be discrepancies between what gets parsed by DOM Purify and what gets parsed by the browser via inner HTML. Because inner HTML has some, internal quirks where it tries to fix up errors. So if you like forget to close a tag, it'll try to close it for you, stuff like that. And this is what's called mutation-based XSS. Basically trying, those fix up routines, stuff like that, to try to get XSS injected into the page, even if DOM Purify is being used. So that's what the bypass in September was doing. It was using math tags in that one, I believe. Abusing the fact that there's a math-based namespace which has like text nodes and stuff like that, which is different than the HTML namespace. And those tags are treated a bit differently. I'm not too familiar with the other namespaces. But yeah, just like the weirdness between the discrepancies in the namespaces. And the fix for that case was to search for potential mutations in those text nodes in the math namespace, but it didn't account for comments. So this is kind of a bypass of the fix for the previous bypass of DOMPurify. Basically utilizing comments to pull off a similar attack. What I was kind of talking about earlier is, you'll remember I was saying something, you were saying something with the XSS, and sometimes it only hits like one browser. What I thought was weird here was this vector only worked on Chrome and not Firefox, but they did manage to get it to work by Firefox by switching out the comment for a CData tag, which is a bit puzzling to me. I don't know enough about DOM engines of either browser to speculate on why that would be the case, but it seems like a very odd behavior that
So
might be cool to study.
they did actually get one to work on Firefox using normal comments. They have it kind of at the bottom with the update.
Oh, did they? Okay.
Yeah, kind of very bottom. They have an update there that includes one that works for that. I couldn't tell you exactly why the CData one, or why the comment didn't work. Although I will say that the image overview that we get here does a really good job at kind of explaining the transformation that happens.
Yeah, that is
And
an awesome image.
it all kind of comes down to that comment. As you said, they don't look for the comment. Well, what ends up happening is in their original input, you'll notice that it goes math, mtext, and then they have this table tag that's open and they never close it. Then they've got the mglyph, math glyph, and then they have a style tag in there. So in HTML style, the comments are just ignored. But when this thing kind of reorders and tries to fix up all these open tags that don't get closed, it moves the table down to the bottom, which then means that style tag is now instead of being part of the HTML in the table, it's part of the math. And in the math, those style tags, when you put an HTML comment in there, those comments are respected. So then the comment actually works and comments out the end style tag. I did think that was kind of an important thing, because that's kind of one of the aspects that makes this work, because then it ends up closing the comment tag later, and that ends up confusing the confusing DOMPurify in terms of how it will parse things, allowing them to inject that image with the JavaScript in it. But yeah, the image kind of walks through showing like here's what changes and all of that. I think the image is just a really good overview.
Is this similar to the DOMPurify we covered a while ago? Do you remember any details about that? Because I didn't remember the details of the DOMPurify.
I don't remember all of the details on that one either.
Okay.
That said, I do think that maybe kicked off some of the research that is going on now into DOMPurify bypasses.
Yeah. So, this is another
one. Actually, I think that one did deal with the style tags too. It didn't use the math ones, but it did use another half open tag.
I'm just gonna do a quick tag. I'm just gonna do a quick grep to see if I can find anything of when we talked about it. And actually, it's not coming up in my notes, so it must have been a while ago. But
episode 39.
Oh, there you go. Perfect. So this is another example of
the
where
link will be in the description. Sorry to just cut you off there, but
yeah, no worries. But this is another example of where discrepancies between two different parsing engines can cause issues. And we've covered lots of issues that are based on that more higher level description of the issue before. Like we saw it with like Apple with their permission manifests for apps and stuff like that. Like another one of those higher level issues that if you don't think about them can come back to bite you. So ZDI is our final exploit post of the stream. So this is a ZDI write-up about a double evaluation bug in Apache Struts. The problem happens through the support of object graph navigational language. It's a bit of a long term, but OGNL for short. And that's basically, it allows expressions used inside of JSP templates. More specifically, the issue happens when you try to force the evaluation of an attribute from a user-controlled string. So that leads to a double evaluation, which can be used by attackers to inject code and achieve code execution. Now, they say it's not as quite as straightforward as that, because Struts does try to mitigate this as a defense in depth measure. They exclude classes and packages from being accessed from those templates and stuff. But kind of unsurprisingly, they were able to find a gadget through a class that is allowed, which was the taglib factory utility class, and they were able to use that to construct instances of classes that were otherwise restricted. So classes and packages. So think sun.mist.unsafe, java.net, java.io. You already see some of the functionalities that those packages provides that can already be extremely useful for somebody trying to do malicious stuff. Being able to write to the file system, being able to establish a network connection. Now, Apache Struts fixed the issue by ensuring proper validation of input passed through the attributes. But I think the most interesting part of the post for me was the gadget that allowed you to create the class instances. That seems like a weird functionality and seems like something you may be able to reuse in other places. I'm not entirely certain on that, just because the way they fix this issue, I don't know if it could really be reused elsewhere. But I think that was like the bigger takeaway for me from this write-up.
The big takeaway for me about this write-up is that this write-up is long and a lot of information you don't need.
That is
not really not really related to the exploit, but for those of you listening, this write-up also includes information about what an HTTP request is and what the spec is for an HTTP header, what a get parameter is and a post parameter, and the different types of HTTP requests, and a lot of information that honestly, I don't know who the target is for this, because they say this is from like an actual report that they wrote up. I don't know if it was a report done for the Struts team, in which case you would expect that whoever's working on Struts would already kind of know what like HTTP is and like what a URL is, like what an action, like what the action URL. I don't know. It feels like there's a lot of information here that's like dumbing all this stuff down, and then they're like, and here's Open Graph Navigation Library, and like diving right into it. And if you want like the really brief summary, this is very similar. Like it feels like, you know, template injections, where if you're able to control something that gets loaded into a template and then the template gets parsed again, or like even just actually parsed, that's the double evaluation. That's where the vulnerability is kind of coming in. After that, it like that's kind of the root of this, I guess I would say. But just as like the high level review, I don't know. For what CDI's put out before, this report just feels so long and like so much information that isn't really needed.
Feels like it falls short a little bit.
Yeah, like
I could definitely see that. I mean, when I was trying to read through this myself, I was finding that I was skipping paragraphs because I could tell that it just wasn't really relevant to what the issue was. So yeah, I think there was a lot of filler that probably could have been cut out. That being said, what do you think on my, question about it maybe being a reusable gadget in other areas? Like, could this be reused in like a deserialization type attack as well?
I don't think it would be reused in a deserialization just because of how the objects are being constructed. It's possible.
Okay.
I'd have to look at how that object's actually constructed to say anything definitively.
Okay.
But I mean, generally speaking, with deserialization, like, you kind of control. Actually, I guess the other thing with deserialization is if you just have like pure deserialization, you don't need to do the workaround at all. Like you can deserialize to one of the unsafe classes. I mean, many libraries try and defend against it in pretty much the same way Struts did here by looking at the classes that are being created. But I couldn't tell you if this particular class could be reused, but there are other classes that are already commonly used for that.
So, bottom line is this maybe could be used for that, but it probably wouldn't be worth it because you could probably just go with something that already exists anyway and is tried and true.
Yeah, I mean, if it's there and you can use it, like give it a shot. I don't know if you could use it in deserialization exactly.
Yeah.
Like that gadget.
Yeah. Okay. That's no problem. It was just something I was kind of thinking about and thinking of what you could take away and maybe reuse from that article. So, getting into some binary and fuzzing, we have UNIFUZZ. And this is, we're kind of revisiting a topic we've touched on a little bit before, which is the issue of how do you benchmark when it comes to fuzzing. So I think the last time we talked about something similar to this was, talking about FuzzBench back in episode 32. One thing I will quickly say is this name actually collides with a paper we covered a few weeks ago on episode 45. Episode 45, we also had a paper named UNIFUZZ, but that was an entirely different paper. That one was about distributed fuzzing via centralized task scheduling. This one is about benchmarking. So the paper tries to hit that problem of how do you benchmark fuzzers? And the common ways that have been done over the years is results. Does it find things? How many issues does it find? And coverage. How much coverage can it get, with a given set of definitions on a given subsystem? But there's no one true benchmark, as it were, when it comes to fuzzing. When you have like games, for example, you have FPS. There's no FPS equivalent for fuzzing, really. So the authors are trying to solve this by proposing an open source, pragmatic, metrics driven fuzzing platform, they call it. It's a very long string of words. So they basically propose a set of 20 programs that they picked out from various types of programs like image editing and parsing, audio, video, text, binary, network. Um, and they assess 6 types of metrics by trying to fuzz those programs. So those metrics are the quality of unique bugs, the quantity of unique bugs, the speed of finding bugs, the stability of finding bugs, coverage, and overhead or resource usage. So I mean, when it comes to these types of metrics, some of them I think are reasonable. Quality or quantity of unique bugs and speed of finding bugs definitely matters when you're talking about fuzzing. Some of the other ones, though, they do seem odd to me to include, like quality of bugs. Generally, when you're fuzzing, you don't really care about the quality of the bugs you're finding. You just want to find bugs. Triaging the bugs is kind of a separate thing. So it does seem weird to me that they would include that in their metrics for benchmarking fuzzers.
Well, a fuzzer that I think finds higher quality, more severe bugs, or harder to find bugs can generally, I think, be considered a better fuzzer. Like, I think that's kind of where they're going at it from. That said, I think their automation of that is a little bit lacking with their use of basically GDB extension exploitable and trying to map the crash to a CVE and using its CVSS score. CVSS, as we've talked about in the past, and it doesn't quite capture everything. Like, it has its place, but
it has much to be desired, especially when it comes to binary, I find.
Yeah. And then exploitable for the GDB extension, again, just kind of an automated analysis. Can have some issues. It just kind of makes a determination like, is this likely exploitable or not? Or a few other states too, but I mean, trying to do that, like, it's really hard to just measure the quality of a bug automatically and just from the crash without taking any more time to actually look into the bug itself. But I can kind of get where they're coming from. Like, I don't necessarily think that's a bad metric. It's just a hard metric to measure.
I mean, it's so hard to measure that we've actually covered papers in the past that go specifically into doing that. I forget the name of the paper because I just thought about it. I wish I, had this in advance, but we covered a paper that talked about trying to triage, I think it was heap overflows, trying to assess how exploitable they would be automatically built on top of
You're
fuzzing.
Talking about Kobe?
Maybe that sounds
was the out
like
of bound,
it would be...
right? It did exploit generation. It tried to take your out of bound right and basically expand it out as far as it can go, like get all the gadgets out of it and stuff. A little bit different than just the triage, but
kind of the same vein. There were a few other metrics that I found weird though, like stability of finding bugs. I don't really know what that means. Does it mean like how many bugs you're finding per hour or something? Because
no, so they talk about it. It's your standard deviation. So they would run the fuzzers for a set amount of time or whatever, multiple times, and then how consistently it if it found like 5 bugs one time and 20 bugs the next, and then 2 bugs the next time, it would have a very large standard deviation after so many runs. It would look for if you had a lower standard deviation in terms of the amount of bugs found between each run. And it also considered the number of times the same bug would be found. Finding the same bug multiple times was considered to be of higher stability. And that one, with fuzzing, you want some randomness in there. So it feels really weird to be going for the stability of the findings.
It feels like you're trying to take the indeterminism out of the fuzzing, which doesn't, it's antithetical to what fuzzing is, really. So, yeah, it seems a bit weird for me. Especially because...
Do you want your fuzzer always finding the same thing? Sorry.
Well, that's what I was going to try to get into, was like, if your fuzzer's always hitting the same thing, if that bug is blocking coverage of deeper code that could potentially have more bugs, then it's a bad thing, right? Because that is an issue that has been encountered in various areas, especially areas where recovering from a crash takes a long time. Like, let's say, having to reboot a hypervisor or reboot a kernel or something like that. Encountering the same bug over and over again is definitely not a good thing. It actually blocks progress and stalls out the fuzzer. So that's another thing where I think it's weird to include that in the metric, because it makes it sound like finding a bug over and over again is always going to be a good thing, which it isn't really, in my opinion.
Yeah, well, one of the things this paper doesn't do very well is they don't really cover, like, they make a lot of assumptions. They assume like the stability of finding bugs is a good thing, and they don't really defend these assumptions. They just
Yeah.
list these metrics that they're looking for, and like, okay, it's their paper, they can do what they want. But they just kind of list them without really defending why those are the right metrics to look for. And that's kind of the issue with so many fuzzing things is, they just choose, the benchmark programs they want. Like, there's no real basis for a comparison, and then they don't defend why they chose anything. Like, sometimes it can make sense to make some of the weird choices. In this case, when they're trying to be this holistic and universal setup for it, though, like, I think they should be defending some of these things. Like, it's not necessarily obvious that, especially stability, I think is the big thing, is so crucial. I mean, I think you can come up with an argument for it, and I would have appreciated if they spent a bit more time doing exactly that. The other thing is overhead. The actual cost and consumption. Like, a good fuzzer, like, I'm not going to care what its overhead is. I think a more important thing would be, does it scale well? But the overhead itself is a little bit less of an issue than just what does it find and does it find. Like, the overhead's just kind of, it's related, but it doesn't matter as much.
Yeah, I think what they were going for there was like, especially when it comes to like memory usage and stuff, being a limiter of how many you can run in parallel on the same machine, which it's just they talk about memory usage and CPU usage, and it just feels weird because, okay, memory usage, I could see why you would want to keep that as low as possible. CPU usage, the more CPU time is being spent fuzzing, the more it's doing. So it doesn't really make sense to try to lower that. You know what I
They
mean?
mentioned that, though, and one of their conclusions is, like, if it drops below 80%, something's probably messed up.
Yeah.
The other thing they looked at was disk IO. That was another one of their metrics. They're under overhead.
Which is a fair
But
overhead. Like, if you can keep things in memory, then it makes sense too. Because disk IO
the
can
thing
bottleneck.
is, or the thing I'd kind of come back to is that, the overhead itself isn't as much of a concern as how well something scales. I think that scaling aspect is what needs to be looked at, not just overhead, because the overhead, just looking at that, kind of assumes the linear scaling, which isn't always the case. So, I mean, if you want to talk about, how many you can run, it's, actually take a look and see what it does as you start pushing the limits. Not this kind of artificial look at it. Oh no, I feel like it just lacks dimension.
Yeah. And what you were saying there with like lacking defending on some of the choices, it does make it seem like, this benchmarking does seem like it could be influenced from bias, which is something you don't really want when you're benchmarking. You want it to be as objective as possible. And when it's not clear why you think something is a good metric, then it makes it kind of blurry. And that's a problem when it comes to benchmarking.
Yeah, I'll
Um,
kind of add in there, like, they also kind of lack any sort of review of prior work. Like, so many of these papers we cover end up talking about, like, prior work that's done something similar, other benchmark systems in this case, other approaches to it. And they just kind of jump right into it. They don't really talk about too much of the other Like, I guess they do say, like, lack of pragmatic real-world benchmark programs. But I feel like they could have talked about some of the other papers that have kind of covered similar things.
Yeah. Now there is one thing I noticed. They had a paragraph that I thought was interesting, saying that we found 15 serious flaws among fuzzers they tested and reported them, and more details at like 16, I think they gave. And I think archive is pre-review, right? So there it's not super uncommon that there's like mistakes and stuff, but some of their links in their references are broken. So they mentioned like 16, and I wanted to see some of these details they were talking about with the serious flaws among other fuzzers. And they have a GitHub link, and the GitHub link goes to a 404. It's not actually a valid link. I don't know if that's just because it's a repository that they haven't made public yet, which could be the case. But I did want to try to get some more information there, and I was kind of left stuck when the link didn't work. And they do have a repo that is up, but when I checked it, I'll link it. I'll bring it up on the stream here. It doesn't seem to have much. It basically just seems to have downloads for the programs that they're going to use in their benchmarking, and like nothing else really. So
There's more if you go to like their main like account. If you just go to the UNIFUZZ account rather than the specific repo, you do kind of get a few more things out of it, like the seeds. You can get all of the Docker. Well, not all of them. I think they make mention of like 35 fuzzers, and I don't think there's 35 listed here. They say they instrumented in Docker like a lot more than what we see here.
yeah.
But there's more. If you do go out to their account, there are a few more repositories to look at. But
Overall, I think it's an interesting problem to try to tackle. I just think that it should have been their metrics should have been fleshed out more and made more obvious as to why they exist and why they're important and how much impact they should have. Because the other thing I was wondering, it could just be because I missed it and didn't see it in the paper, but are they giving all of those 6 assessment metrics equal weighting? Because they didn't seem to mention like how if they would be weighted differently. In which case, I feel like they should be weighted differently. Like, I don't think it's fair to measure, resource usage and overhead and say that's equally as important as the quantity of bugs found.
well, I don't
Like, I
think they
just
necessarily make any conclusion on that. They just give all the data, so they have all the pretty pictures and charts of the results that they saw. They don't really
they
make
don't
the
really collate it
conclusion. Like
into a
they don't.
centralized metric.
Yeah.
Yeah.
I mean, as you're saying, like it's a discussion that needs to be had. It's something that we've talked about a few times, is the lack or the odd choices that some fuzzers have made when they do their benchmarking. So, I mean, this is a discussion that's important to be had, needs to get fleshed out, so we do have a better way of comparing fuzzers against each other. So this is kind of a start. I will say there is one other issue, is we don't have any sort of baseline truth when it comes to the fuzzing, so it's hard to compare performance. Like, they're looking at how many crashes that it can cause in part of it, when they're looking at the quality of crashes and stuff. But there's kind of an unknown number of those to begin with, so you don't know how many it's discovered out of how many there are. And that's where they do make some mention of Lava M, which I don't believe we've talked about at all, but the idea there is that it will inject vulnerabilities, or it did in like the Lava M dataset injected vulnerabilities into several programs. It's a Lava being large scale automated vulnerability edition. And I kind of like that idea because that way you know what's being found. Like you've got a ground truth to compare against. I don't necessarily think Lava M is a good choice there. Like Lava M in particular, it injects vulnerabilities. you have, what is it? It's like it injects like a branch with a 4 byte random value, which if the fuzzer finds that value, it'll trigger the bug. So like it basically tests its ability to, match a 4 byte random value. Like it doesn't capture many other types of bugs or many other conditions. Like I get where they're coming from with that, but it's a little bit insufficient. But at the same time, that's another thing that's kind of missing with the benchmarks is basically something to give it like a concrete value.
Which is very important. Generally, when people want to look at the performance of something, they want one number. They don't want to look at six. So that's that's kind of a gap that is left to be desired to be filled there.
And I will kind of give a shout out. I don't actually know if this was a joke or not, but it sounds like there might be some look at doing a basically like porting bugs back into programs. That way you kind of know it's there and you make them accessible again. But apparently the paper coming out was to be called Magma. So I don't know if people were joking about that as it just being another thing based off of lava, but I do think that's an interesting idea itself. Although it would take a lot of effort to do that, but it would create a bit more of a standard comparison.
Yeah, I don't see how you could easily do that from an automated standpoint. I mean, I've
Almost
actually
certainly won't be automated.
yeah, I've actually gone back and done that before in just personal stuff I've done. I've monkey patched vulnerabilities back into stuff to try to test something after it's been patched instead of having to go back and recompile a really old, source. But yeah, that does seem like something that would have a lot of manual overhead to be able to do to the point where I don't
Well,
really know how it could be viable.
I mean, it doesn't need to be automated. Like, you don't need to do every vulnerability. You just need a set of binaries that do have the known real vulnerabilities back in there. Like,
Yeah.
it only needs to be done once, or, once per architecture type thing. It doesn't need to be done, like, for every vulnerability. So there's overhead, but once it's done, it's done.
Yeah, that's a fair point.
That said, like I say, it's an interesting idea, but I don't actually have a copy of the paper to see it or know if the people were just joking about that or not. Like I said, the name makes it sound like it could be a joke. But I don't know. I thought it was an interesting idea that got mentioned, so I wanted to bring it up here.
That being said, we'll move into our last topic of the episode, House of Money or House of Money. I don't know. I don't know how you would
Oh no,
want to pronounce that. Up
I
to you.
mentally was saying Muni. That said, I looked up the word and apparently it is just a accepted alternative to money as a spelling.
There we go, House of Money. So
So
this article builds on the Qmail RCE we saw a little while ago. We covered it back in episode 43, which was the last episode we took before our summer break. Um, and this article mostly tunnels in on the exploit technique where they fake the allocation size and munmap an arbitrary amount of memory. So Markswell Doolin, who authored this, wanted to do more of a beginner-friendly write-up, and dubbed the attack the House of Money attack, and the MUN in money comes from munmap. So yeah, it goes into some of the background of how heap chunks are managed in GNU-libc and how large chunks are mapped internally. It also goes into some background on how symbol resolution works at runtime with like else and stuff like that, and how those two concepts come together to form the basis for this attack. Abusing the mmap and munmap syscalls to overlap a chunk with the beginning of libc to replace the dynamic symbol table. Um, so it breaks down that attack. I'm not going to go like super in depth into it because we did cover it in episode 43. So if you want, us talking about that, you can go and check that out. But they also provide some of the pros and cons of the technique. So notably, pros, it can be used to bypass ASLR because you can use relative offsets in the dynamic symbol table, which I don't think we covered in the Qmail issue, but I can't remember
well, I don't think we
100% on
called
that
it
point.
out specifically.
Yeah. Um, And by extension, that means you don't need a separate info leak to exploit cases where you can use this. Some of the cons, though, this isn't going to work against a full rel row compiled binary, which is something that was mentioned in the Qmail write-up as well. Full rel row prevents lazy loading, so you're not going to be able to just, overwrite that memory. The libc version also has to be known in order for you to provide valid offsets, and you need to be able to control the size of the mmap chunks to pull off the attack. So, when it comes to thoughts, I think this is a really good overview of the exploit strategy, and it makes it more accessible to beginners. I like the breakdowns of mmap and munmap and the symbol resolution stuff. Something I've been thinking about for a while is I never really saw any good resources talking about dynamic linking and how it works in else. There's docs available on like Oracle and stuff, but they're very dry and they don't go deep into it. You basically have to figure it out yourself by sitting down for hours looking through documentation.
It is a lot of black magic.
Yeah. So, it's always nice to see stuff that kind of enlightens on those areas. And I wish I had a resource like this when I was in the early stages of writing the PS4 toolchain and I had to figure out how this stuff works. So it's cool to see that gap getting filled a little bit here. And I do want to shout out, they gave us a shout out in the article as well for talking about the Qmail exploit, which is really awesome. If you're watching this episode, I really like this write up. I think it's really awesome how it's structured and how beginner friendly it is. And I think it really accomplished its goal of explaining it more in depth and pulling it out of like decoupling it from the Qmail specifics of that RCE.
Yeah, I mean, this is taking it from there's that cool attack on Qmail to generalizing it into a house of attack. It's got a house of name, so it's legit. But no, it's a good write-up. That's why I want to kind of give it a shout out on here, cover it quickly. Again, we're not going into all the details of the attack because we kind of covered it already, and it does the job well enough. If you want to know, definitely give it a read. I do also appreciate they do have a GitHub attached to this, or repo attached, which includes basically a walkthrough, ownable-ish, highly commented, just makes it really accessible to learn this as an attack. And I think there's a lot of value in having this sort of practice area with it. Because with a lot of these heap attacks, just generally speaking, it's really useful to kind of grok it or to kind of intuitively understand what's going on. And you get that by actually playing around, by having the binary open, having the debugger open, looking at how things are changing, and really understanding what's happening, getting that, understanding. So the inclusion of that is really nice. So I appreciate that a lot for just recommending it as a resource. But when it comes to the heap attacks in general, a lot of them are just... So when I first read Malloc Maleficarium, so, way back in 2003 or 05 or whatever that was.
Back in the old days.
Yeah, well, when I first... That was kind of my first wake-up call to what I would say seeing the art of exploitation. And seeing a lot of the creativity that still comes into it. And I mean, that's the thing with a lot of these heap attacks, you don't you're not necessarily going to be pulling a lot of these off. There's specialty requirements for a lot of them. In this case, you need to be able to control the size of those allocations for the mum mapping and stuff. And it's maybe not going to be the most common situation, but the creativity that goes into thinking of how you're going to abuse, this one little bit of control, how do you leverage that? That's what so many of these heap attacks do, is they just leverage this little thing into something larger. So I think there's just a ton of value in being able to play around with them and really understand the issue, not because you're going to need to exploit that issue, but because it gives you that understanding that you can use on other issues.
Yeah, I'd agree there. So I think that pretty much sums up all of our topics. Thank you to everyone who tuned in. You can catch the VODs on Twitch or on YouTube 24 hours after the stream. We also have previous podcasts up on Spotify, Apple Podcasts, Google Podcasts, and we have more links on Anchor FM. Keep a lookout for our discussion video coming this Thursday about programming languages. You can join our Discord and follow us on Twitter if you want to get involved with the community and know immediately, when stuff goes up and when we're going live and stuff like that. That being said, we will be back next Monday at the same time, 3 p.m. Eastern, 12 p.m. Pacific, and we'll see you guys then.